Okay, we're going to do another problem related to moles and counting, and then we're going to bring in a new topic again. So this problem is related to the Toyota Corolla problem that I posed earlier. If you have a dozen Toyota Corollas, how many wheels do you have? And the idea was that there are 4 wheels per car. If you have a dozen cars, then you have 1 dozen times 4 wheels, which is 48 wheels. Uh, we're going to do a similar type of problem with this molecule. This is the formula for a chemical called sulfuric acid. The formula is H2SO4, and I've sort of tried to give you a cartoon version of what this molecule looks like down here. So each hydrogen is a red circle, each sulfur is a yellowish-orange circle, and each oxygen is a blue circle. And you can see that one molecule of sulfuric acid has 2 hydrogen atoms, 1 sulfur, and 4 oxygen atoms. So that's a sulfuric acid molecule, this whole thing here. Now come the questions. And again, you can pause at various points and try to answer them. First question is, if I have 1 mole of sulfuric acid molecules, how many sulfuric acid molecules do I have? You can pause here to try and address this question. This one should be relatively straightforward again. If you have 1 mole of sulfuric acid molecules, how many molecules do you have? Well, 1 mole is 6.02 times 10 to the 23 things. So 1 mole of sulfuric acid molecules is 6.02 times 10 to the 23 sulfuric acid molecules. So that one is relatively straightforward as long as you know what 1 mole equals. Next question. How many hydrogens do you have if you have 1 mole of sulfuric acid molecules? You can pause and think about this. The answer is basically based on the fact that if this is 1 molecule of sulfuric acid, every 1 molecule has 2 hydrogen atoms. And the question is, how many hydrogen atoms do you have? Well, if you have 1 mole of sulfuric acids, you have 6.02 times 10 to the 23 sulfuric acid molecules, and there's 2 hydrogens for every 1. So how many hydrogens do you have altogether? The answer is 2 times 6.02 times 10 to the 23. Which is 1.204 times 10 to the 24 hydrogen atoms. Next question. How many sulfur atoms do you have? Again, you can pause and think about this. The way you address this question is the same way. You say, look, how many sulfur atoms are there for every 1 H2SO4 molecule? Well, there's 1 sulfur. So if I have 1 mole of sulfuric acid molecules, I also have 1 mole of sulfur atoms because there's only 1 sulfur for every molecule. So the answer there is just 1 times 6.02 times 10 to the 23, which turns out to be Avogadro's number again, 6.02 times 10 to the 23 sulfur atoms in 1 mole of sulfuric acid. Next question. How many oxygen atoms do I have? And hopefully you can see the pattern coming up here. You can pause if you'd like. The way of addressing this question is the same way that we've addressed the previous 2 questions. In other words, you say, look, how many oxygen atoms are there for every 1 molecule of H2SO4? There are 4 oxygen atoms for every 1 molecule, but I have 6.02 times 10 to the 23 molecules of sulfuric acid, so I must have 4 times as many oxygen atoms. And so the answer there is 4 times 6.02 times 10 to the 23. Which is about 2.408 times 10 to the 24 oxygen atoms. And again, hopefully you can see that this is related to the car question that I asked earlier. Here there are 4 wheels per car. Here there are 4 oxygens per molecule. There also happen to be 2 hydrogens per molecule and 1 sulfur per molecule. But the principle is the same as the way we figured out the number of wheels on a dozen cars. So at this point, I want to extend the idea of molar mass. A few slides ago, we said that molar mass was how much 1 mole of something weighs. So I'm going to show you a miniaturized or a shortened version of the periodic table. Here are some elements that you can refer to. First question is, what's the mass of 1 mole of hydrogen atoms? This is just me asking what's the molar mass of hydrogen. Well, we go over to hydrogen here, and the mass of 1 mole of hydrogen atoms is about 1 gram. Again, I'm rounding to the nearest whole number. So we can say 1 mole of hydrogen atoms weighs about 1 gram. Next question. What's the mass of 1 mole of oxygen atoms? Again, you look over here at the oxygen box, and you say, well, 1 mole of oxygen weighs about 16 grams. Again, I'm rounding to the nearest whole number. So this is relatively easy, right? I'm asking you, what's the molar mass of hydrogen? It's this in grams. What's the molar mass of oxygen? It's about 16 grams. Next question. What's the mass of 1 mole of water molecules, of H2O? Now, for some of you, this may be relatively easy to figure out. For others of you, it might be pretty difficult. So I'm going to pause here, have you think about it. If you'd like, you can pause as well. And then I'll talk about what the answer is. So the way to address this is, if you have 1 mole of water molecules, actually the first thing I want to point out is that everything that we've talked about so far with respect to moles has dealt with atoms, more or less. I've basically said you could have 1 mole of hydrogen atoms, and that's 6.02 times 10 to the 23 hydrogen atoms. But you can have 1 mole of anything. You can have a mole of cars, you can have a mole of people if you wanted to, and you can have 1 mole of water molecules as well. What this means is you have 6.02 times 10 to the 23 water molecules. And what I'm asking is, if you have 6.02 times 10 to the 23 water molecules, how much does it weigh? The way to figure this out is you just break the water molecule into its component pieces. Well, look, if you have 1 mole of H2O molecules, you have 2 moles of H's, because there are 2 hydrogens for every molecule. So how much does 1 mole of hydrogen weigh? It weighs about 1 gram. How much does 2 moles of hydrogen weigh? It weighs about 2 grams. So you already know how much 2 moles of hydrogen weighs. How much does 1 mole of oxygen weigh? Well, it weighs about 16 grams. And if you have 1 mole of H2O molecules, you also have 1 mole of oxygen atoms. So now, figuring out how much 1 mole of water weighs is just tantamount to adding up the weights of all of the pieces. 1 mole of H2 weighs 2 grams. 1 mole of oxygen weighs about 16 grams. So 1 mole of water weighs about 2 grams plus 16 grams, which is 18 grams. So the punchline is that you can, well, one of the punchlines is that the weight of a molecule depends on the weight of its atoms. And you can figure out how much 1 mole of anything weighs as long as you know its chemical formula, and as long as you can look up the rest of the information on the periodic table. So 1 mole of H2O weighs the same amount as 2 moles of hydrogen and 1 mole of oxygen, which turns out to be 18 grams. And you can do this for anything as long as you have access to the periodic table and as long as you know the formula. So here come some examples. This is just a more detailed version of what you should do if you want to calculate the molar mass of a molecule. Again, you can figure out the molar mass of any material if you know its chemical formula. What you do is you look up the molar mass of each individual element in the molecule. So as the example here, we'll do water again. You look up the molar mass of each individual element. So we have hydrogen and we have oxygen. The mass of hydrogen, the molar mass of hydrogen is about 1.0079 grams. Molar mass of oxygen is about this much, almost 16 grams. Then you multiply each molar mass by the number of atoms for each element. So for water, there are 2 hydrogens. So we have to multiply this number by 2. For oxygen, there's only 1, so we multiply this number by 1 if we want to, but that's a little bit of a waste of time. And then you add up all of the numbers that you get. So if you multiply this by 2 and add 15.999, you end up with 18.014 grams of water in 1 mole of water. What that means is, another way of saying that is, if you have 1 mole of water, it weighs this much. Another way of saying it is, the molar mass of water is 18.014 grams per mole. Another way of thinking about it is, if you have 6.02 times 10 to the 23 water molecules, altogether they weigh about 18 grams. I just said the same thing about 3 different ways. And it may take some time to become accustomed to thinking about all of those 3 different ways. So here's a little bit of practice. So what's the molar mass of carbon dioxide? The relevant information from the periodic table is here. You can think about this for a minute. You can pause the video and think about it and work it out. The way to do it is shown here. You basically look at this formula and you figure out the molar mass of each element. Well, there are only two different elements here. There's carbon and there's oxygen. So the molar mass of carbon is 12 grams per mole. So that's here. The molar mass of oxygen, just O all by itself, is about 16 grams per mole. So I'm just rounding up. But we have two oxygens for every molecule. So we have to take 16 grams and multiply it by 2, because we have 2 moles of oxygen atoms in 1 mole of CO2. 2 times 16 is about 32 grams. So in 1 mole of carbon dioxide, we have about 32 grams of oxygen atoms. And in 1 mole of carbon dioxide, we have about 12 grams of carbon atoms. You add up all of those pieces, 12 grams plus 32 grams is about 44 grams of carbon dioxide. So more formally speaking, the molar mass of carbon dioxide is 44 grams of carbon dioxide for every 1 mole of carbon dioxide. The part that tends to be confusing to people is that the molar mass is usually not written this way by chemists. This is a little bit too much detail. What they usually do is cut a little bit of the corners and they say the molar mass of carbon dioxide is 44 grams per mole. So a lot of times students who are new to chemistry will see this, and it's a little bit confusing because you're not that familiar with the ideas yet, and you say 44 grams. Well, 44 grams of what? And per mole of what? What they're really saying is that the molar mass of carbon dioxide is 44 grams of carbon dioxide per 1 mole of carbon dioxide. Now, another way of saying it, again, just to emphasize this, if you have 1 mole of carbon dioxide, or if you have 6.02 times 10 to the 23 carbon dioxide molecules, those will weigh about 44 grams. I'm just rephrasing what molar mass is here. So again, you can do this type of calculation for any molecule where you know the chemical formula. The next question is going to be a little bit more difficult. Here's the question. You have 100 grams of sodium chloride. This is the formula for sodium chloride. That's how it's pronounced. It's 1 sodium atom and 1 chlorine atom. Sodium chloride, in case you don't know, is just the more formal chemical name for table salt. You have 100 grams of table salt. How many moles of table salt do you have? And again, this requires a little bit more calculation than we did on the previous slide. The relevant element information is here. You can pause and work on this now. So the way to do this is you need to perform a couple of mathematical steps. The first thing you need is you need to figure out the molar mass of sodium chloride, or the molar mass of table salt. That doesn't give you the answer, but you need that piece of information to use as a reference. So the first thing we'll do is we'll figure out what the molar mass of sodium chloride is. Molar mass of sodium chloride is just adding up the pieces, the molar mass of sodium and the molar mass of chlorine, because there's only one of each in a molecule. So 22.99 grams plus 35.453 grams is about 58.44 grams of table salt for every 1 mole of table salt. Now, the way that more experienced chemists will write it, even for new chemistry students, is they'll write it this way. And this, again, can be a little bit confusing to say the molar mass of table salt is 58.443 grams per mole. If it helps you to think about it in the more expanded way, we'll do it that way for now. Basically, what that means is if you have 58.44 grams of table salt, you have about 1 mole of table salt. And vice versa, if you have 1 mole of table salt, you know that it weighs about 58.44 grams. So 58.44 grams of table salt per mole. That doesn't answer the question because we have 100 grams of table salt, but we can use this fraction as a reference to compare 100 grams. The way to do that is as shown here. You basically say, look, there are 58.44 grams of table salt for every 1 mole of table salt, but I don't have 58.44 grams. I actually have 100 grams of table salt because that's what the question says. So how many moles is 100 grams? You set up this equal fraction over here. You want to figure out what x is, so you cross multiply. You do 58.44 times x is equal to 1 times 100. And that's shown here. 58.44 times x is equal to 1 times 100. We want to get x all by itself. We have to get rid of this guy over here, so we divide both sides by 58.443. If we do that, we get x moles of sodium chloride is equal to 1 times 100, which is just 100 again, divided by 58.443, and x turns out to be 1.71 moles of table salt. So the answer here, just in case this is a little bit confusing to you, is basically telling you that if you have 100 grams of table salt, if you actually weighed out on a scale 100 grams of salt, you would have 1.71 moles of salt, of table salt. And so that might be somewhat difficult for some of you. If it is, you can sort of try to play it back. You can do some of the suggested problems, or you can contact me and we can talk about it. So we basically reached the end of the unit. You know, you can ask the question, why does chemistry use the mole instead of the dozen? The reality is that when you are scooping out chemicals and weighing them out in the lab, you are weighing relatively large, you're using relatively large numbers of molecules and atoms. And the mole is just a simpler way of grouping those large numbers of atoms into numbers that are easier for you to understand. So instead of saying I'm using 6.02 times 10 to the 23 molecules of water, you might say I'm using 1 mole of water, because that's a little bit easier to understand. And obviously it's extremely difficult to weigh out a dozen molecules of water. They just don't weigh enough to register on conventional scales, and it's just hard to grab them. Let's see. And then just to summarize, the entire unit, we started out talking about chemical formulas. Hopefully you now know how to read them and to write them, if I gave you enough information. We talked about counting atoms and molecules and basically introduced the idea of what a mole is. A mole is just a certain number of things, a very large number of things. We talked about weighing atoms, really atomic mass. And there are different ways of describing the mass of atoms. You can talk about individual atoms or small numbers of them, in which case you would use Daltons. If you're talking about moles of atoms or molecules, then you're usually describing the mass of those groups of atoms in grams. And we also talked about molar mass, which is how much 1 mole of something weighs. And then finally we talked about converting between number of molecules, number of moles, and the weight of those molecules or atoms. So that's the end of Unit 5, which is covering the first half of Chapter 5. Next unit we will do the second half of Chapter 5, which builds on the stuff that we've talked about here.